think of it as your unified control tower for the entire operation. This might look complex, but the concept is very simple. In essence, it does four things beautifully. It basically ingests data from your IoT sensors, processes it to find anomalies, lets you monitor everything in real time, and automatically alerts the right people when an issue is detected. And as Pavel mentioned earlier, it's basically about moving from reactive to proactive. Let's imagine there's an automobile manufacturing company, and in its factory, there will, of course, be an assembly line, which I believe all of you are pretty familiar with. There are multiple stations on that assembly line, and some of them have a punching machine, let's say. Now, let's install IoT devices on those machines, which are always connected to the internet, wired or wirelessly, depending upon the factory situation, and have various sensors like temperature, current, power drawn, vibration, coolant level, load ratio, etc. These devices are constantly sending values of these parameters to the cloud, and of course, AWS in this case, every 5 to 10 seconds. Now, this will go through the entire data pipeline that we just saw a couple of slides back. IoT code to Kinesis, parsed by Lambda and stored in hot and cold manner at the same time. All this data gets stored in specialized databases like TimeStream, again, AWS. And this can be visualized via tools like Grafana. And again, everything is happening inside AWS itself. But instead of me just describing it, I think it's better to show how the outcome might look like. I'm now going to switch the screen share. And here we go. So let me just give you a disclaimer before we start. So basically, all this is based on real-time data, which is coming in from a simulated factory. It's not a real factory which is sending in the data right now. It's basically a simulated factory that's running digitally, sending the data, and it's being captured by our AWS tools and then being presented here in the best manner possible. So as a line supervisor, I'll be able to see the same on a dashboard like this. Today, I'll be showing you two dashboards, a live one on Grafana for real-time monitoring and a historical one on QuickSight for past analytics. Let me allow you 10 seconds to just quickly glance through the screen as I slowly browse through them. These are pretty self-explanatory, so I won't be digging deep into each and every KPI individually. Let's have a quick look at how these look like. This is basically the live one, wherein data is being sent from the machines every 5-10 seconds, and the dashboard is being refreshed as well. It's a complete live one, real-time system. And the second one, this is the historical database. Like you collect your data, and then basically this will help you perform analytics on top of it to make decisions before something goes wrong. One important thing to note here is that these reports or visuals you see on the screen are fully customizable, which will be built as per the sensors or parameters you have, the machines you are monitoring, your factory conditions, color theme of your company, etc. So in short, the charts, KPIs, values, look and feel, everything can be changed to basically suit your requirements in particular. Now, in this case, I have, let's say, 30 machines which are active at any given point of time. And this is as per my production quota requirement. I need to have these many machines, at least these many machines working at all the time in order to fulfill my monthly or quarterly quota, basically. But as an experienced plant manager, I know that these machines are very high maintenance and can go into an inactive state, requiring servicing multiple times a day across all of them together. Hence, I have a few of them in backup so that in case where a machine goes into maintenance, I can still continue my production line with a backup. Now, this takes place within a minute or two itself. It can happen via AWS itself, or it can happen manually via my team. As you would have seen on the screen just now, a particular machine just went off and another machine took its place. And I can see my running machines has gone down from 30 to 29, which is a concerning issue for me because this will reduce my production quota. And but immediately I'll also get an email about the same with the machine details, why it went into maintenance, what was the error code, if any, etc. Just a reminder, please feel free to put down your questions on the chat, and we'll get back to them very soon, and there will be a Q&A session in the end as well. Similarly, I think I can also have a detailed look at a particular machine if required, to see if it is working properly or not, whether all the parameters are within the expected ranges or not. Is any machine going towards a point of failure right now? Yes, this is an interesting thing that we might want to have a look at ourselves. So let's just say we have selected a particular machine here, and I'm just analyzing this data itself. And interestingly, I can actually see that the temperature of this machine is increasing. Now here you can actually define a range for your all the different sensors that you put in your machine, all the different parameters that you want to capture about your machine. You can put them into a range, and then if something goes beyond that range, that is when an alert will be created for you. And for now, as example, I can see that this particular machine's temperature went beyond 192 degrees, 196 right now. And I think I should be getting an email for this. Yes, there should be an email immediately, which will force my team to stop this machine, because probably there could be multiple reasons. Now, looking at this, I can figure out that the temperature went up because of a coolant issue. It does sound like a very common thing to know that, of course, the temperature has gone up because of coolant issue. Now, the problem might be with the fact that if this particular machine goes into high temperature again and again, you can in fact go and check the coolant leakage. What if there's a leakage going on in the machine itself, because of which the coolant drops and the temperature rises? And as you can see on the screen, this is the kind of email that I get. Low coolant level alert, with the percentage, with the device details. And this is all completely automated, based on the sensors and based on the ranges that you would have customized yourself for your particular machine. This is not like an out of a box directly. You take the product and you put it on your machine and it will work. You will have to configure a bit, but that configuration will in fact save you a lot of money and time in the long run. So that is what we are mainly doing here. We are basically trying to be proactive instead of being reactive after something has happened. We are trying to predict, and how to predict we'll probably have a look at in the next dashboard, wherein so every day, every 5-10 seconds, we are collecting this data. Okay, in the cloud databases. Can we do something with this? Of course we can. And this is again where AWS and all the different tools that AWS has to offer, it comes in. And this is where the cold data pipeline comes into picture. We can regularly move the live data into a traditional analytics database on a daily basis, even multiple times a day if you want. It can be done weekly, monthly, or 15-20 times in a day as well. It's completely as per your requirement and the type of factory or the type of manufacturing you're running. And as you have seen this data, this dashboard a few minutes back, I'll directly jump into an interesting feature of this dashboard. As you remember, the KPIs and charts are all customizable. But what if even after customizing, you have a question in mind that doesn't get answered via these pages? Here, I introduce another cool tool from AWS called Amazon Q. Instead of telling you what it is, I'll just quickly show you what it can do. Like, let's say I want to know the top 5 machines that have gone into maintenance the most number of times in the last month. Here, I immediately get the results like this. This is not one of the charts which is present in the dashboard itself. So you can actually do a lot of custom queries here. We have tried multiple things. A lot of things work. And yes, it gives you pretty good results in terms of analyzing and understanding how your machines are behaving in the past. Like, it can actually even get you like what is the average machine uptime by shift code, top 5 machines that have the highest load in the last 7 days. I can even just like for example, here itself on the screen, you can see that one particular machine that has gone into maintenance 64 times in the last 1 month. I can take that particular machine itself and ask it a basic question that what has been the minimum and the maximum temperature range of this particular machine. You won't find that anywhere in the dashboard, but I can quickly write it in plain English, in a very simple language. I can just query it and it will give you the result. And of course, in the dashboard also, I can have a look at that particular machine in detail, and I can see that that particular machine's utilization was 21% weekly, which is pretty low as per my production standards, and it has gone down 36% in the last 1 week itself. Now, this is concerning. So from here, we can go into our shop floor, we can look at that machine, we can see why that is happening, we can take preventive measures, and etc. We can do a lot of different things. And a lot of those things as well can be done using AWS itself, but I think we'll cover that in a separate session.